On the morning of October 14, 1943, 291 Boeing B-17 Flying Fortresses lifted off from airfields across East Anglia, England, and formed into combat boxes over the Channel. Their destination was a small Bavarian city that most of their crews had never heard of 6 months earlier, but that they now knew by a single gut-tightening syllable: Schweinfurt. The name translates as pig crossing. The men in the bombers had other names for it. They called it the slaughterhouse. The bombers were unescorted. The P-47 Thunderbolt fighters that were supposed to protect them could only fly as far as the German border before their fuel ran low and they had to turn back. The inexplicable decision not to equip the fighters with drop tanks, which would have extended their range by hundreds of miles, was a failure of logistics that would cost hundreds of lives. From that point on, for over 2 hours of flying time each way, the B-17s were alone over Germany. The Luftwaffe was waiting. German fighters hit the formations before they crossed the Rhine. Focke-Wulf 190s and Messerschmitt 109s came in waves, attacking from head-on at a closing speed of over 600 miles per hour, from the flanks, from above and below. Some carried BR-21 rockets, unguided weapons the size of a man's arm that they fired into the tight bomber formations from outside the range of the B-17's defensive machine guns. The rockets were not accurate. They did not need to be. A near miss was enough to damage a bomber's control surfaces, knock it out of formation, and leave it straggling behind where the next wave of fighters would finish it off. Wounded bombers trailing smoke attracted German fighters the way blood attracts sharks. The sky over central Germany filled with burning aircraft, trails of descending parachutes from crews who had managed to bail out, and the black smudges of flak bursts from thousands of anti-aircraft guns below. The crews in the bombers could do nothing about the flak except fly through it. There was no evasion, no countermeasure. You held formation and you held course, and you listened to the sound of shrapnel hitting the aluminum skin of your aircraft, and you waited for the bomb run to be over. Some men prayed, some men froze, some men did their jobs with a mechanical calm that astonished them afterward when they had time to think about what they had done. The bombers that survived the gauntlet dropped 485 tons of high-explosive and incendiary bombs on the target. The 5 ball-bearing factories in the city were hit hard. Buildings collapsed. Machine oil ignited. Smoke rose thousands of feet into the autumn sky. Then the surviving bombers turned for home, and the Luftwaffe hit them again. By the end of the day, 60 B-17s had been shot down. That was more than 20% of the attacking force. Another 17 were damaged beyond repair. Over 600 airmen were dead, captured, or missing. The 305th Bomb Group alone lost 130 men, 87% of its crews. The 306th lost 100. 1 crew in 4 did not come back. The mission was later called Black Thursday. The American daylight bombing offensive was suspended. No more deep raids into Germany without fighter escort. The price had been too high. The raids would resume in February 1944 during a week of concentrated attacks known as Big Week. But by then, the P-51B Mustang had arrived, a fighter with the range to escort bombers all the way to Berlin and back. Schweinfurt was hit again during Big Week, this time with fighter cover, and the losses were more sustainable. But by February 1944, Speer's dispersal program was well advanced. The concentrated target that had existed in August 1943 was already dissolving into a network of small facilities that no strategic bombing campaign could efficiently destroy. This was actually the second time the Americans had tried. The first Schweinfurt raid had taken place 2 months earlier, on August 17, 1943, as part of the Schweinfurt-Regensburg Double Strike Mission, one of the most ambitious and disastrous operations of the air war. The plan was elegant on paper. 376 B-17s would split into 2 forces. One would hit the Messerschmitt fighter factory at Regensburg and then fly on to North Africa, drawing the Luftwaffe southward. The second force, following 10 minutes behind, would turn northeast and bomb Schweinfurt while the German fighters were on the ground refueling. The weather ruined the timing. Fog over England delayed the second force by 3 hours. The element of surprise was lost. By the time the Schweinfurt bombers crossed into Germany, the Luftwaffe had landed, refueled, rearmed, and was waiting. The result was carnage. 60 bombers were lost across both targets. Albert Speer reported an immediate 34% reduction in bearing production, but both the production shortfall and the actual loss of bearings were quickly made up from reserves found throughout Germany. The Americans had achieved a temporary dent, not a lasting wound. The August raid taught the Germans what was coming. They began dispersing their factories immediately. When the Americans returned in October for the second raid, they were bombing a target that was already being evacuated. But had it worked? The answer, which would take months to fully understand and years to honestly admit, was no. The bombing of Schweinfurt did not break the German war machine. It did not even come close. And the reason it failed reveals one of the most extraordinary and morally ambiguous stories of the Second World War. A story about a Swedish company called SKF that sold ball bearings to everyone. A company that kept the machines of both sides turning. A company that proved that in modern industrial warfare, neutrality is not absence from the fight. It is the most profitable position in it. To understand why ball bearings mattered enough to justify sending 600 men to their deaths, you need to understand what a ball bearing actually does. The principle is ancient. If you place a heavy stone on top of logs, the stone slides easily because the logs convert sliding friction into rolling friction. Rolling friction is orders of magnitude lower than sliding friction. A shaft rotating inside a plain sleeve bearing must overcome the friction of metal sliding against metal. The heat generated by that friction limits how fast the shaft can spin, how long it can operate, and how much load it can carry. A ball bearing eliminates the sliding. An inner ring rotates with the shaft. An outer ring is fixed to the housing. Between them, a set of hardened steel balls rolls in precision-ground grooves called raceways. The shaft spins on a cushion of rolling steel rather than a surface of sliding metal. The reduction in friction is dramatic. This matters in ways that most people never consider. Every rotating shaft in every machine requires a bearing. The crankshaft in a tank engine, the propeller shaft in a submarine, the turret ring that allows a gun to traverse, the control surfaces of an aircraft connected to the pilot's stick through cables that pass over pulleys running on bearings, the axles of a truck, the spindles of a machine tool, the rotors of an electrical generator, the wheels of a railway car, the gyroscopes in navigation instruments and bomb sights, the propeller governors that control engine speed in flight. Wherever metal turns against metal under load, there must be a bearing. And in the precision machinery of 20th century warfare, that bearing was almost always a ball bearing or its close cousin, the roller bearing. Manufacturing them was an exercise in precision that bordered on the obsessive. The balls had to be perfectly spherical to within millionths of an inch. The raceways had to be ground to mirror smoothness. The steel had to be hardened to a precise specification, hard enough to resist wear, but not so hard that it became brittle. The tolerances were so tight that a bearing factory was more like a laboratory than a machine shop. Temperature, humidity, and cleanliness were controlled as rigorously as in a surgical theater. A single speck of dust trapped between a ball and a raceway could cause a bearing to fail, and a bearing failure in a fighter engine at 20,000 feet was not an inconvenience, it was a death sentence. The German aviation industry alone consumed an estimated 2.4 million bearings every month. A single Messerschmitt Bf 109 fighter required dozens of bearings in its engine, propeller hub, landing gear, and control linkages. A Tiger tank required hundreds. A submarine required thousands. The entire German war machine was a vast assembly of rotating parts, and every rotating part depended on bearings that had to be manufactured to tolerances measured in 10,000ths of an inch. This is why American war planners identified ball bearings as a bottleneck, a single point of failure in the German industrial system. Destroy the bearing factories, the logic went, and every factory in Germany that depended on bearings would eventually grind to a halt. The tanks would stop rolling off the assembly lines. The aircraft would stay on the ground. The submarines would never leave port. One target, attacked successfully, could cascade through the entire enemy war economy. It was an elegant theory, and it was catastrophically wrong. The men who flew the Schweinfurt missions understood none of this strategic calculus. They knew only what they had been briefed. The target was a ball bearing factory, and ball bearings were important. They flew because they were ordered to fly. The statistical reality of their situation was grim. American bomber crews were required to complete 25 missions before they could rotate home. At the loss rates sustained over Schweinfurt, the mathematics were merciless. The odds of completing 25 missions at a loss rate exceeding 10% were, for a mathematician, a depressing exercise. For the men who lived inside those odds, it was a daily confrontation with mortality. The crews developed rituals and superstitions, lucky scarves, specific sequences for climbing into the aircraft, photographs of wives and girlfriends tucked into flight jacket pockets. Some men wrote letters home before every mission and left them on their bunks to be mailed if they did not return. Others refused to write, as if acknowledging the possibility of death would invite it. The ball turret gunner, who sat in a rotating glass sphere beneath the belly of the B-17 with his knees pulled to his chest and twin 50-caliber machine guns between his legs, had the most exposed position on the aircraft. If the hydraulics failed, the gunner could not get out. If the landing gear was shot away and the bomber had to belly land, the ball turret was crushed first. It was the position nobody wanted and somebody always had to fill. These were the men who were sent to destroy the bearing factories. College boys from Iowa and mechanics from Brooklyn and farm kids from Texas crammed into aluminum bombers at 25,000 feet in temperatures of -40 degrees, wearing oxygen masks that froze to their faces, firing at fighters that came in so fast they were in and out of range in 3 seconds, dropping bombs on a target they could barely see through the smoke. And the target they were destroying was being resupplied from Sweden the entire time. The theory was wrong for several reasons, but the most important one was a company. Svenska Kulagärfabriken, the Swedish ball-bearing company, known universally by its initials SKF, was founded in Gothenburg, Sweden in 1907 by an engineer named Sven Winquist. Winquist had invented a self-aligning ball bearing, a design that could tolerate slight misalignments in a shaft without seizing or overheating. It was an elegant solution to a common industrial problem, and it made SKF one of the most successful manufacturing companies in Europe within a decade. By the time war broke out in 1939, SKF was the largest ball-bearing manufacturer in the world. Its headquarters and main production facilities were in Gothenburg, Sweden, a neutral country. But SKF also owned subsidiary factories across Europe, including, crucially, in Germany and Britain. The Vereinigte Kugelfabriken, VKF plants in Schweinfurt were SKF subsidiaries. The very factories that the Americans were bombing at the cost of hundreds of lives were owned by a Swedish company that was simultaneously selling bearings to Britain. The irony goes deeper. SKF did not merely happen to have subsidiaries in Germany. The company had deliberately established factories in the countries that were its largest customers, a strategy of vertical integration that made perfect commercial sense in peacetime and created an impossible moral geometry in wartime. The VKF plants in Schweinfurt, which produced roughly 20% of Germany's bearings, were managed by German employees under German law, using German materials and German labor. But the profits flowed to Gothenburg. The patents were Swedish. The engineering standards were set by the parent company. The Kugelfischer plant, which produced another 22%, was a separate German company, but it too operated within the orbit of the global bearing industry that SKF dominated. When the Americans bombed Schweinfurt, they were destroying German production capacity that belonged to a Swedish company that was also supplying Britain. When Albert Speer, Hitler's armaments minister, rebuilt the damaged factories using forced labor from concentration camps, the engineering knowledge that guided the reconstruction came from the same Swedish technical tradition. The entire ball-bearing industry was a web of cross-border ownership, licensing agreements, and technical relationships that made the clean distinctions of wartime propaganda, Allied good, Axis evil, neutral irrelevant, seem hopelessly naive. This was the central paradox that the Allied bombing strategists either did not understand or chose to ignore. Destroying the factories at Schweinfurt would reduce German domestic bearing production, yes, but it would not cut off Germany's access to bearings because Germany could buy them from Sweden, and Sweden was selling in enormous quantities. The numbers are staggering. Research conducted after the war using Swedish, German, and British archives established that SKF and its subsidiaries controlled approximately 58% of German ball bearing supplies and 31% of British supplies. Sweden was not a minor supplement to either side's production. It was the backbone. Both the Wehrmacht and the Royal Air Force depended on Swedish bearings for their most critical applications. Sweden sold more to Germany than to Britain. The exports were not hidden. They traveled by rail from Gothenburg across Swedish territory and then through occupied Norway or Denmark to reach Germany. The Swedish government knew. The German government depended on it. The British government tolerated it because Britain also needed Swedish bearings and could not afford to antagonize the Swedes into cutting off supply entirely. It was, from a certain angle, the perfect business arrangement. Both belligerents needed what SKF produced. Neither could afford to attack Sweden for fear of driving it into the other side's camp, and SKF, sitting in the middle, supplied both, charged both, and profited from both. The British, however, had a much harder time getting their bearings out of Sweden. Germany controlled the sea approaches. The Skagerrak, the strait between Denmark and Norway, was patrolled by the German Navy. Swedish ports on the North Sea coast were effectively blockaded. British access to Swedish ball bearings required either air transport, which was limited in volume, or blockade running, which was dangerous and unreliable. The story of how Britain got its Swedish bearings reads like an adventure novel because it essentially was one. The key figure was George Binney, a British businessman who had been the representative of the Iron and Steel Federation in Sweden before the war. Binney was a large, eccentric, impossibly brave man who refused to accept that Germany's control of the Skagerrak meant Britain could not get its bearings. In January 1941, he organized Operation Rubble, in which 5 Norwegian merchant ships that had been laid up in Swedish ports since the German invasion of Norway slipped out of Gothenburg under cover of a winter storm and ran the German blockade. All 5 made it. They delivered approximately 18,000 tons of material to Britain, including ball bearings, machine tools, and specialty steels. For this, Binney received a knighthood. A second operation, Performance, in March 1942 was less successful. 6 ships sailed. The Germans were expecting them. 2 were sunk, 2 were forced back to Sweden, and only 2 reached Britain carrying 27% of the original cargo. Binney changed tactics. In late 1943, he launched Operation Bridgeford using 5 converted motor gunboats. Originally built for the Turkish Navy, these small, fast craft were stripped of their armament and fitted with cargo holds. They were fast enough to outrun German patrol vessels and small enough to be nearly invisible at night. Operating out of Hull, they dashed across the North Sea to the Swedish port of Lysekil, loaded 40 tons of cargo each, and raced back. Between October 1943 and March 1944, they completed 6 return voyages, carrying approximately 347 tons of ball bearings and other critical materials through the German blockade. 347 tons. That is what it took. Converted gunboats running through minefields and patrol zones in the middle of winter because Britain could not live without bearings that a Swedish company was happy to sell to both sides.
Meanwhile, the RAF also flew bearings out of Sweden. De Havilland Mosquito bombers, modified to carry cargo in their bomb bays, flew from Scotland to Swedish airfields and back, their speed and altitude making them nearly impossible for the Luftwaffe to intercept. These flights carried approximately 88 tons of bearings and related materials. Every ton was precious. Britain was so desperate for certain sizes of bearings, particularly those under 1 inch and over 4 inches in diameter, used in tanks, aircraft, and heavy motors, that the shortage was considered a genuine threat to war production.
The Americans took a different approach. If they could not cut off German access to Swedish bearings through bombing, they would try to buy them instead. In early 1944, Foreign Economics Administrator Leo Crawley sent Stanton Griffiths, the chairman of the executive committee of Paramount Pictures and a man with considerable charm and business acumen, to Stockholm. Griffiths carried an astonishing offer. The United States would pay up to $30 million to purchase SKF's entire output, effectively buying every bearing the company produced and denying Germany access. SKF listened politely and declined. The company could not afford to cut off Germany entirely. Sweden was surrounded by German-occupied territory. Germany supplied Sweden with coal, coke, iron, and chemicals that the Swedish economy could not function without. Germany also supplied Sweden with weapons, including anti-aircraft guns and ammunition. If SKF stopped selling to Germany, Germany would retaliate by cutting off those supplies. Sweden would freeze in winter. Its factories would close. Its military, which depended on German armaments, would be weakened. The Swedish government calculated, correctly, that an open break with Germany would be national suicide. And SKF calculated, also correctly, that its position at the center of the global bearing market was its greatest protection. Both sides needed it too much to destroy it. The negotiations became a three-way chess match. The Americans pressured Sweden to reduce exports to Germany. The Germans pressured Sweden to maintain them and backed their demands with economic coercion. When Sweden showed signs of yielding to Allied pressure, Germany retaliated by reducing coal shipments by 1 million tons, suspending deliveries of coke-smelted pig iron that Swedish industry needed, and cutting off supplies of synthetic rubber. Sweden was being squeezed from both sides, and the commodity being fought over was not a weapon, it was a small steel sphere. In 1944, under the tripartite war trade agreement, Sweden agreed to lower its ball bearing exports to the German bloc to 29 million kroner, about a third above its 1943 level. It was a concession, but not a capitulation. Ball bearing steel, a critical component for manufacturing bearings, was explicitly excluded from the restrictions. The Americans turned up the heat. The Treasury revoked permission for SKF Industries, the company's American subsidiary based in Philadelphia, to send dividends to Sweden. The move backfired spectacularly. Workers at the Philadelphia plants, confused by the negative publicity, believed the bearings they were making were being shipped to Germany. Slumped foreman workers. The Work Production Board's vice chairman, who was also the president of SKF Industries in America, had to stand on a flag-draped platform and assure 8,000 workers that they were making bearings for the U.S. military, not the Wehrmacht. The entire episode illustrated the impossible tangles that neutrality created in total war. An American company, owned by a Swedish parent, making bearings for the American military, while its Swedish parent simultaneously sold bearings to Germany, was punished by the American government, causing American war production to drop. The War Department, which had lost 60 bombers and 600 men trying to destroy bearing factories in Germany that were owned by the same Swedish company, was reduced to sending a Hollywood executive to Stockholm with a checkbook.
Albert Speer, Hitler's Minister of Armaments and War Production, knew about the Swedish connection and considered it a lifeline. But Speer also understood that depending on any single source was dangerous. After the first Schweinfurt raid in August 1943 reduced German domestic bearing production by 34%, Speer launched a massive dispersal program. Bearing production was moved from the concentrated factories in Schweinfurt to dozens of smaller facilities scattered across Germany and occupied territories. Some were hidden in tunnels carved into mountainsides. Some were in the basements of apartment buildings. Some were in repurposed garages and warehouses in small towns that no bombardier would ever target. The labor for this dispersal came largely from the concentration camp system. Speer's industrial empire was built on slave labor, and the ball-bearing industry was no exception. Prisoners from camps including Flossenburg and Sachsenhausen were put to work in the dispersed bearing factories, operating precision machinery under conditions of starvation, brutality, and exhaustion. The bearings they produced went into the machines of the regime that was enslaving them. It was a closed loop of industrial horror. The dispersal worked. When the Americans returned to bomb Schweinfurt in October, they destroyed buildings that were already partially evacuated. The machine tools had been moved, the workers had been reassigned, the production had been distributed so widely that no single bombing raid could knock out more than a fraction of it. Speer also found alternatives to ball bearings in many applications. Slide bearings, which use a simple lubricated surface rather than rolling elements, could replace ball bearings in lower-speed, lower-precision machinery. Engineers redesigned equipment to use plain bearings wherever possible, reserving ball bearings for applications where nothing else would work. The German habit of engineering everything to the highest possible precision had led to the overuse of ball bearings in applications that did not actually require them. Under the pressure of bombings and shortages, German designers learned to be more practical. The result was that despite the devastating raids on Schweinfurt, despite the diplomatic pressure on Sweden, despite every effort the Allies made to strangle the German bearing supply, Germany never ran out of ball bearings. Production dropped temporarily after each raid. Schweinfurt's output was severely affected. But the combination of dispersal, Swedish imports, accumulated reserves, and substitution ensured that Germany's war machine kept turning. Arthur Harris, the head of RAF Bomber Command, had been right all along when he called ball bearings a panacea target, a solution that promised more than it could deliver. By 1945, Germany had assembled more bearing reserves than at any previous point in the war. Speer himself acknowledged the danger after the war. "When you hit Schweinfurt," he told his interrogators, "it was like a nightmare coming true, because I always thought bombing our bottleneck industries would be much more effective than bombing cities." He admitted the damage was serious, but he also described how his deputy, a man named Kessler, organized repairs, substitutions, and the redistribution of existing stocks to bridge the gap. Reserves were found in military depots across Germany, bearings that had been stockpiled and forgotten. Army units hoarded bearings in quantities far exceeding their needs. When these hidden reserves were identified and redistributed, the immediate crisis passed. The lesson was clear. Destroying a factory is not the same as destroying an industry. An industry is a system, and systems have redundancy built into them, not by design, but by the natural accumulation of surplus, stockpiles, alternative suppliers, and human ingenuity under pressure. The deeper lesson of the Schweinfurt story is not about bombing accuracy or fighter escorts or industrial dispersal. It is about the nature of modern industrial economies and the limits of strategic bombing as a weapon. The Allied planners who identified ball bearings as a bottleneck were not stupid. Their analysis was logical. If a machine needs bearings and cannot get them, the machine stops. If enough machines stop, the factory stops. If enough factories stop, the war stops. The logic was impeccable. The problem was that it assumed a static system, a system in which the enemy would not adapt. But the enemy always adapts. Speer dispersed production. Engineers substituted slide bearings. SKF sold from neutral territory. Reserves were found in warehouses across Germany. The system was not static. It was dynamic, resilient, and ruthlessly inventive under pressure. The 600 men who died over Schweinfurt on Black Thursday died because of an analytical failure that confused theoretical vulnerability with actual vulnerability. The ball bearing industry was theoretically a bottleneck. In practice, it was a target that could absorb enormous punishment and keep functioning through a combination of redundancy, imports, substitution, and sheer German industrial determination. The real bottleneck, as later analysis would reveal, was not ball bearings, but oil. The oil campaign of 1944, which targeted German synthetic fuel plants and Romanian oil fields, achieved what the ball bearing campaign could not. Without fuel, dispersal meant nothing. Without fuel, the tanks sat idle regardless of how many bearings they had. Without fuel, the Luftwaffe could not fly, the Kriegsmarine could not sail, and the Wehrmacht could not move. Oil was the true single point of failure, and when the Allies finally attacked it systematically, the German war machine did collapse, rapidly and irreversibly. The contrast between the two campaigns is instructive. Ball bearings could be stockpiled. They were small, durable, and did not degrade in storage. A warehouse full of bearings represented months or years of supply. Oil could not be stockpiled in the same way. It was consumed immediately, and synthetic fuel production required enormous industrial plants that were vulnerable to bombing and could not be easily dispersed. A synthetic fuel plant was a vast chemical complex covering acres of land, with towers and pipes and storage tanks that could not be hidden in a garage. When these plants were hit, fuel production dropped within days, not weeks. By the summer of 1944, the oil campaign had reduced German aviation fuel production to a fraction of its previous level. Pilots were being trained with fewer and fewer hours of flight time. New aircraft sat on airfields without enough fuel to fly them. Tank units were immobilized. The Ardennes offensive in December 1944, Hitler's last gamble in the West, was planned with the explicit objective of capturing Allied fuel dumps because Germany no longer had enough of its own. The ball bearing campaign, for all its cost in blood, had achieved none of this. It was the wrong target, attacked with extraordinary courage. But what about SKF? What happened to the company that sold bearings to both sides? Nothing. Nothing happened to SKF. After the war, there were investigations. There were questions in Parliament, both in Sweden and abroad. There were academic studies and journalistic exposés. The Americans, who had pressured SKF throughout the war, conducted inquiries through the Foreign Economic Administration. The British, who had depended on SKF for their own survival, were in no position to complain too loudly. The entire affair was wrapped in the kind of diplomatic silence that descends when all parties are implicated and no party wants the full truth to emerge. But SKF had operated legally under Swedish law. Sweden was a neutral country. Neutral countries were permitted to trade with belligerents. SKF had not violated any Swedish statute. The company had navigated the war by supplying everyone, charging different prices to different customers, maintaining its market position on both sides, and emerging from the conflict with its factories intact, its reputation largely undamaged, and its global market share stronger than ever. The pricing tells its own story. In 1938, SKF charged Britain 74% of what it charged Germany for the same bearings. By 1943, the discount had widened to 68%. Britain got cheaper bearings than Germany. Whether this constituted a violation of neutrality, as some historians have argued, or was simply shrewd business, as others maintain, depends on your definition of neutrality and your tolerance for moral ambiguity. SKF today remains one of the largest bearing manufacturers in the world, headquartered in Gothenburg, employing over 40,000 people across more than 100 countries. Its wartime history is acknowledged but not dwelt upon. The company's official centennial history, published in 2007, covers the war years with the careful neutrality that has been the Swedish national stance on the subject for 80 years. There is a question that the Schweinfurt story forces us to confront, and it is not a comfortable one. If a neutral company sells a critical component to both sides of a war, and both sides depend on that component, does the company bear moral responsibility for the suffering that both sides inflict? The men who died in the bomber formations over Schweinfurt were killed by German fighters in flak. The Germans who died in the bombed factories were killed by American bombs. The British soldiers whose tanks ran on Swedish bearings and the German soldiers whose tanks ran on the same company's bearings were killing each other with weapons that shared a common origin. SKF's bearings were in the engines of the Lancasters that bombed German cities and in the engines of the Messerschmitts that tried to shoot them down. The company did not build weapons, it built components, small, precision-manufactured steel spheres that reduced friction. That is all a ball bearing is, a small sphere of steel in a machined groove. It has no ideology, it has no allegiance, it does what physics tells it to do, which is to roll. But without it, nothing else moves. The tank does not drive, the plane does not fly, the submarine does not dive, the machine tool does not cut, the factory does not produce, the war does not function. That is the power of the component. It is too small to be seen, too fundamental to be replaced, and too profitable to be withheld. Today, the ball bearing industry is global. Annual worldwide production exceeds 100 billion units. They are in every car, every airplane, every hard drive, every wind turbine, every electric motor, every medical scanner, every industrial robot. The modern world spins on ball bearings as surely as the wartime world did. China, Japan, Germany, and the United States are the largest producers. The industry generates over $90 billion in annual revenue. SKF remains a dominant player alongside Japanese giants like NSK and NTN, and the German company Schaeffler, which traces its lineage directly to the Kugelfischer plant in Schweinfurt that the Americans bombed in 1943. That plant is still there. It still makes bearings. The craters have been filled, the rubble has been cleared, the slave laborers who worked the dispersed factories during the war are dead. The machines are newer. The principle is the same. A steel ball in a precision groove, converting sliding friction to rolling friction, making the world turn. And the strategic calculus has not changed either. In 2023, a Russian missile struck an SKF factory in Ukraine, killing 3 employees. Russia's embassy defended the attack, accusing SKF of supplying bearings to the Ukrainian defense industry. SKF said it manufactured bearings primarily for the civilian automotive sector. The echoes of 1943 were unmistakable. A bearing factory, a military target, a neutral company caught between belligerents. The argument that bearings are civilian components being used in military applications, the impossibility of drawing a clean line between the two. The Schweinfurt raids cost the United States over 120 bombers and more than 1,000 airmen killed or captured across the 2 major missions in 1943. Those men flew into the most heavily defended airspace in Europe to destroy factories that were rebuilt within weeks, that were dispersed within months, and that were being resupplied from Sweden throughout the entire campaign. The blood that was shed over Schweinfurt bought a temporary reduction in bearing output that German ingenuity, Swedish commerce, and the realities of industrial economics quickly erased. The lesson is not that the bombers should not have gone. The lesson is that in a modern industrial war, there is no silver bullet. No single target, however theoretically vital, can be destroyed in isolation from the global system that supplies it. The Germans knew this. Speer knew it. SKF knew it. The only people who did not know it were the men in the bombers, who were told that if they could just hit the factories hard enough, the war would shorten and lives would be saved.
They hit the factories. They hit them hard. They lost friends and brothers doing it, and the bearings kept rolling. From Schweinfurt, yes, but also from Gothenburg. From subsidiaries and subcontractors across occupied Europe. From stockpiles and reserves that nobody had bothered to count. From slide bearings and plane bearings that engineers hastily substituted. The system absorbed the blow and kept moving, because that is what industrial systems do. They adapt. They route around damage. they find another way. The ball bearing did not care who used it. It rolled for the Allies and it rolled for the Axis. It was manufactured in neutral Sweden and shipped to both sides through channels that were legal, profitable, and morally indefensible by any standard, except the standard of sovereignty and commerce, which is the only standard that neutral nations have ever recognized. 600 men died over Schweinfurt on Black Thursday. They died bravely, following orders, doing what they believed would end the war sooner. They were wrong, but that was not their failure. It was the failure of a strategy that imagined the enemy's economy as a machine with a single weak point, when in reality it was a network with 1,000 alternative paths. And one of those paths ran through a factory in Gothenburg, Sweden, where a company called SKF manufactured small steel spheres of extraordinary precision and sold them to anyone who could pay for the right price. From a factory in a country that had chosen to sell rather than to fight. It is a story of the limits of destruction and the persistence of commerce, about the difference between breaking a machine and breaking a system, and about the men who flew into the fire to learn that lesson at a cost that the strategists who sent them never had to pay.